invite me to give a talk. And I also thank Wei Jun very much. You helped me a lot prepare the conference. Thank you. So today my topic is uncertain financial engineering. So I will give a brief overlook of the development of uncertain finance engineering in this field. In the field of uncertain financial engineering, the first question is that how do we describe the future price? Yeah, you need to find a tool to describe the future price. So for one period model, yeah, you use the like this. Yeah, you use like this. Okay, like this. And this is a discrete model. We can also use the discrete model for multi-period. But this is a discrete model. Today we will talk about a continuous model. Yeah, before we introduce uncertain model, the stochastic model is frequently used. Here you can find we use a stochastic differential equation to describe the future price of some financial asset. Yeah, xt is the price of the financial asset. Mu is the drift, and the sigma is the diffusion of the financial asset. Yeah, this model is very popular. Yeah, you can see a lot of theoretical or practical application of this model. But this model is not enough. Yeah. Besides this model, in stochastic theory, they also they also create a lot of other models like martingale or Levy process, something like that. But they also all of the models are in the framework of probability theory, so they have a big problem. The biggest problem is that in stochastic model, they use the dW over dt to describe the noise. Here, W is the Brownian motion. Yeah, Brownian motion. Also, you can call it a Wiener process. This noise has a probability distribution with the expected value 0 and the variance. The variance is infinity. So this is a very big problem in the application of the theory. So Professor Liu create a new tool. Yeah, this is the Liu process. Yeah, Liu process here. It is Liu process. For Liu process, we use the dct over dt. This part as the noise, and this noise follows the uncertain normal distribution with the expected value 0 and the variance is 1. Yeah, I think in our real life, you cannot imagine something the noise has a variance infinity. Yeah, so I think this this model is more acceptable for our real life. So based on this model, Professor Liu create the theory uncertain differential equation theory. So here is the uncertain differential equation. So we often use xt to represent the asset price, and here R is the drift, and the sigma is diffusion, and the ct is a Liu process. It is not a Brownian motion, it is a Liu process. Yeah. So uncertain financial engineering theory is a theory based on Liu process. Also is a theory based on uncertain differential equation. So all our works are based on this very strong tool. I think in future, maybe we can create more process like some to describe the jump or describe some more complicated model and situation. But today we also we will focus on the new process. Yeah, it is a very powerful tool, and it opens the way to the uncertain financial engineering theory. Yeah. In uncertain in financial engineering theory, we need to use some process to describe the future price, and then we use the basic financial concept to find the price of some financial contract like derivatives or like option future and other like other things like option like bond and something like that. Yeah. So our talk, yeah, we are focused on the first three part. First is the stock market. The second is the bond market. Third is foreign exchange market. Yeah. All these part are based on a new process. It is a very different theory from Brown motion, and because the variance of the noise is follows 0 and 1 normal distribution, so it is very powerful to apply it. Yeah. So the first model is introduced by Professor Liu 10 years ago. Yeah. Here, in the uncertain market, there are two assets. One is bond. Yeah. Another one is stock. The bond follow a ordinary differential equation, and the stock follow uncertain differential equation. Yeah. And use these two assets, we can find the price of option, the European option, American option, Asian option, and some other options like that. Yeah. So this market is very brief, but it has a very strong theoretical background and a theoretical application. So because in our model, theoretical model, two assets is enough. And here R is the riskless interest rate, and E is the drift, sigma is the diffusion. And I know that Professor Liu and his group focus on the field to estimate the drift and diffusion, use the theoretical data. So this is the future work. So you can use the data to estimate the drift and diffusion. After you get the estimation, yeah, your model will be better, I think. So this is a very, very powerful theory. And today we will first assume that the drift and the diffusion and the risk-free, riskless interest rate are constant number, and to derive the formula. So first we will calculate the European call option pricing formula. So a European option is a contract that gives the holder the right to buy a stock only at an expiration time and for a strike price key. So this option only can trade at the expiration time S. Yeah. So this time at time S, the price of the stock is very important. So based on the one price rule, that is a very important rule in financial field. We give the price formula. The embedded payoff and discount times the discount rate. Yeah, this part is the discount rate, and this part is the expected payoff of this contract. Because the European option only give you payoff, the call option give you the payoff that when the stock price is greater than the strike price. So the payoff is YS minus K, and take the positive part and take the expectation. So this is the payoff, and this is the discount. Because the future in the contract happens in future time as like that. So this is the pricing formula. After we have this price formula, the next question is that we want to find the value of this formula. So this is a very important formula for option, and to give the solution is a very important work in uncertain differential equation. Very fortunately, this work has been done by Xiaowei and me. We give a theorem that first we give the solution, the alpha path of the uncertain differential equation. That is alpha solution of the uncertain differential equation. And based on alpha path of uncertain differential equation, we can very easily get the expected value of some function of the solution. Here, if we have a function j that is increasing or decreasing function, on xt, then the expected value of this after the function, it is just take the integration between 0 and 1, j xt alpha. So this formula give our the solution, because you can find that the pricing formula is increasing with the underlying stock y. So when y go up, so the option price will also go up. So we give the solution. Okay, so there is we can use the Xiaowei formula to give the formula of the option pricing formula. And so we put the alpha path of uncertain differential equation in the European option formula. And we get the value of the European option pricing. It is very easy. You can find the formula is here. And this is the call option. And for put option, the story is the same. You can find a put option is give the right, give the holder the right that to sell a stock at its present time for strike price. So the payoff of European put option is k minus y, take the positive part, and the expected payoff is like this, and we take the discount and get the pricing formula. And also this formula is decreasing with the underlying stock price y. When y go up and the put option price go down, so you can find it is decreasing with the underlying stock price. So we can use the Xiaowei formula again to find the price formula. So it is very easy to get the price formula. And for American option, also it's not very difficult to find the pricing formula. For American option, the difference between American option and European option is that if you hold an American option, you can exercise before the expiration time. You can choose any time between time 0 and the expiration time. So the payoff is the maximum of the discounted expected value of the payoff. So we take the maximum of this part. The maximum also increasing with the underlying stock price. So we can use the Xiaowei formula again, and we put the alpha path into the pricing formula. and calculate the American option price and take the discount and find the formula. So this is very brief. But before we find the Yeltsin formula, it is very difficult to calculate this value. Yeah, because this formula is created before Yeltsin formula. So before that time, we need to calculate the distribution of this maximum and find the expected value, use the uncertainty distribution. Yeah, that is another story. But here now we have the very powerful formula, and we can just put the or insert the alpha path into the formula, pricing formula, to get the solution. It is very easy and very useful. And you didn't need to use the PDE method or something like that. You just insert the alpha path. Yeah. So it's very brief and very easy. And the same thing for American put option pricing formula. Yeah, for American put option price formula, the payoff is K minus YT. This is the trade payoff, and take a discount because we can exercise at between time 0 and the time S. So we need to take a maximum. So this maximum takes the expectation. Then we get the pricing formula for American put option. And also we use the same way. We put the alpha path into the formula, get the solution. Yeah. And if we move our attention to Asian option pricing formula. Asian pricing formula, we take the expectation or the average of the sometime period average of the underlying asset as the traded underlying asset price. And for Asian call option, you can find the payoff is just the underlying asset price minus the strike price, take the positive part and take the expectation and discount it. So this is the payoff. Very brief. Very fortunately, our Yeltsin formula can be used again to calculate this part. Calculate the expected valuation. So we just put the alpha path solution into the formula and get the pricing for Asian option price. For Asian put option, it is decreasing with the average of the underlying asset price. So we just put the alpha solution into the formula again to get the solution of the formula. So it's very interesting. So this method is very popular, and a lot of professors have used this method to study plenty of option pricing problem. They publish a lot of papers. If you're interested in this part, you can go to online our uncertainty theory lab to find the papers. So this is a very interesting and very useful theory to in our financial market in the stock part because in our financial market there are three parts. The first part is stock market. The second part is bond market. The third part is foreign exchange market. So we also apply the uncertainty differential equation into the bond market. So in the bond market, the underlying uncertain future price value is the interest rate, or you can call it SALT interest rate. So this is a changeable value, and if you watch read the news from the newspaper that the interest rate change with time. Yeah, nowadays I think all over the world the interest rate is very low. Yeah, it's near zero. Yeah, because all over the world I think the global economic is not very good, so they will lower the interest rate to put more money in the market to make the economics better. Yeah. So, but in the future, I read the news from Chinese people that they think that in the next year the Chinese GDP growth rate will go to 9.50, not 9.5%, the growth rate. And they say that the interest rate will go up twice time in the future 1 year. So you can find that the SALT interest rate change with time and change with the macroeconomics. So we want to use the uncertain differential equation to describe the SALT interest rate. The first model was created by me and Professor Gao. Yeah, we described the SALT interest rate use an uncertain differential equation. Yeah, M is some long time level of the interest rate, and A is the speed that the interest rate go to the long time level, and sigma is the diffusion. Yeah, this is one model, one SALT interest model, and Jiao and Yao, they also create another SALT interest model to describe the SALT interest rate. Yeah, the difference between our the two models is this part. Yeah, so you can find his model is more complex than our model, but our model have an analytic solution. So because our model was created before the Xiaowei Chen formula was founded, so at that time this model cannot be solved. So we created this model. But after Xiaowei Chen formula, they created this model. Yeah, use the Xiaowei Chen formula to get the solution. So that is the old story. But if you read the stochastic financial engineering book, you can find a lot of models. Yeah, I have read a book. I find at least 30 models. Yeah, about the SALT interest rate. They use different stochastic differential equation to describe this different SALT interest rate. So why? Because there's no one model that is best. So they need to a lot of models to find better one. So, but unfortunately, there is no better one. So they try a lot. So in our theory, also the same. We need to use a lot of uncertain SALT interest rate model to describe different SALT interest rates, and and based on uncertain SALT interest rate model, we first give the price of zero coupon bond price formula. So this is a zero coupon bond. So the zero coupon bond price is just the expectation of the discounted future value of the bond. Yeah, here we assume the bond face value is 1, so we get the pricing formula. And Professor Zhang, Rodriguez, and Liu, they also find the interest rate floor and the ceiling price. Yeah, floor and ceiling price. That is something like option. Yeah, option on SALT interest rate. Yeah. So, but they give another name like salt rate for floor or ceiling, but it is option on salt interest rate. And again, we use the Xiaowei formula and to give the solution. Yeah, you can find, we can put the alpha path. Yeah, I just, so again, the Xiaowei formula, it is very useful. Yeah, you can find, we just put the alpha path into the formula and get the solution of the pricing formula. And also we can put the alpha path into the interest rate floor or interest rate ceiling formula to get the solution. So it's very useful. Yeah. And there are a lot of models. They are focused on different type of interest rate, certain interest rate model. And we also create another model that because in bond market, the interest rate was affected by a lot of macroeconomic factors. The first one is the or the very important one is the inflation rate. So inflation rate is a very important factor that has a direct effect on interest rate. So we in our model we describe the inflation rate use another uncertain differential equation, and this is the salt interest model. Yeah, we use these two differential equations as a system to model the salt interest rate. And yeah, and we also we know that the diffusion can also be different in different time period, because at some time the government will, or the Federal Reserve System will thought that the salt interest rate can move with a bigger volatility, but sometimes they will make the salt interest rate move in at a shorter volatility. Yeah, it depends on the macroeconomic environment. So this part, yeah, the diffusion can also be described by another uncertain differential equation, and we can use this two formula system to describe the salt interest rate. Yeah, in order to get the solution of this system, we also create the uncertain differential equation formula, the alpha path for high dimension uncertain differential equation to get the solution. Yeah, use this alpha path. Yeah, we can get the solution of this formula very easy. Yeah, so you can find that if you want to use more factor model, the first thing is that you need to find the alpha path of the system. Then use the after you prove the system, then you can use the alpha path to get the solution. It's a I think it's a very interesting method. And we also create a three-factor model. Yeah, we put the inflation and the volatility process into the model together, and we also prove the alpha path of the system solution. Yeah, it's not very difficult to prove the alpha path solution. And we put the alpha path solution into the formula, find the solution. And also we describe the default risk, because we know that the bond has default risk. That is a very important property of a bond. I don't know the default risk in India, but in China, because due to the pandemic, yeah, a lot of bond, they have default risk nowadays. Yeah, at least this month, they announced that there are 4 bonds has a default in the last month. Yeah, you can find the default risk is a very important part for bond theory. So we introduce an uncertain differential equation to describe the default risk. Yeah, we model this. We model it use the motility, the force of motility. Yeah, and the force of the motility was described by an uncertain differential equation, and we put the force of the motility into the pricing formula, and to describe the death rate or the hazard rate. Yeah, you can find we put here, and we get the pricing formula. So a bond, this is the bond price without default risk, and this part is the default risk, and we put this part together and get the pricing formula. And we also use the alpha path solution. Yeah, because these two processes are independent, so we are very easy to get the solution of this this pricing formula. Yeah, you can find here. Yeah, yeah, we first need to prove the alpha solution, and they put the alpha solution into the formula. And this is the formula for uncertain sort rate and with the default risk. Yeah, so we put the uncertain sort interest rate and the default risk together into our pricing formula to price bond with the default risk. Yeah. I think in the future maybe we can use the method created by Professor Liu's group to estimate the distribution of this default risk. Yeah, we want to, but in our market, yeah, you can find that the default bond is very few. Maybe you can hear the default news 1 year for only a very few times. So I think uncertainty theory is very important, very useful and very powerful tool to get the estimate of this part. Yeah, there are no sufficient data. Yeah, to estimate the default risk. Yeah. So before the pandemic, I think in China, in the last 3 years, there are nearly no default bond. But this year, yeah, there are 4. Yeah, only 4. There are plenty of bond in our market. So this, I'm trying to ask my students to use the bond market data to get the estimation of this this part, and to pricing the bond with the default risk. Yeah, and the last 2 part is the foreign exchange market, and the asset allocation. Use the allocation, use the optimal control theory. Yeah. So this part I didn't put in the slides because I think yeah, there are a lot of things. Yeah, too many things. Yeah, if you want to read it, I think you can go to the website to find the papers. Yeah. For foreign exchange market, yeah, we just put the foreign exchange rate as the uncertain differential equation, and we derive the option on foreign exchange rate, and we also derive the future price or the other price for you on the foreign exchange rate. For the asset allocation problem, we just describe the asset price, use uncertain differential equation, and make optimal portfolio, use the optimal control theory to find the optimal solution and optimal portfolio. Yeah, that is the all the part of this outstanding engineering theory. So I can give a brief summary that, yeah, if you use outstanding differential equation to describe the stock price or some other price, and then you are open the door to uncertain financial engineering theory. Yeah, if you have have some interesting in this part, you can send me email. Yeah, we can discuss with you. And there are, I think a lot of professors, they have done a lot of work in this part. I have no time to introduce all of their work. So you can find it, all the work from the website. Yeah, thank you. Thank you very much.
So thank you, Professor Xiaowei Chen from Nankai University for your nice presentation. So any questions from participant? So please unmute yourself, and if you have any question, you can directly ask Professor Chen. So Professor, I have a question to you. In your model, how you get or optimize your model? Is there any real life data?
Yeah. Before the numerical the statistical models was founded by the professor's group. We didn't use the data to fit the model, but last year and this year, professor's group have a lot of achievements in the numerical and statistical estimation. So we are trying to use the data to fit the model. Yeah. So we use the real data to fit the model. So then we can compare our models with other models. Yeah.
Okay, thank you. So are you using Mathematica for solve this type of differential equation?
You mean Mathematica, the software?
Yes. Yeah. For solving differential equation?
We often use MATLAB, I think.
Okay.
Yeah.
We are using some Mathematica for differential part, because by hand it become very lengthy. So that's why I'm asking you.
So, but in our group, we are trying to use Python. So now we are using because Python is free, and MATLAB, the same as you, the Zoom is not working in China, and MATLAB was forbidden by the U.S. government in a lot of universities in China. We are trying to move our attention to Python. It is free. Yeah.
Thank you, Professor Chen, for your nice presentation. I hope we will meet again after
Thank
this
you
pandemic.
very much. Thank you. Thank you very much.
So,
thank you.
Thank you very much. So all participants are requested to shift it on Google Meet. Another lecture will be started now by Professor Polas Dotto, Dibrugarh University, and this session will chaired by Professor T. Som, IIT BHU. Thank you very much. Please switch on Google Meet.